We're going to look at this video at proving trig identities. Now there's a whole pile of trig identities here. I'm not going to do them all, but after I've shown you the techniques for a few of them, hopefully we can all work through the rest of them. So the first one we're going to look at is part A, and this is for AS level mathematics. So in AS level mathematics you only have two trig identities. The first one is that tan of x is equal to sine of x over cos of x, and the other one is that sine squared of x plus cos squared of x is equal to 1. So there's only two identities we can use. Okay, for an identity, I'm going to shift those up there out of the way. For an identity, what you must do is work with one side only until you get it equal to the other side. So here you typically use a side, well, you use the side which you can do more with. So I'm writing down LHS, and that stands for left hand side. So my left hand side, and I just write it out again as it is. So it's 1 over cos squared and 1 minus cos squared over tan of x. And then from this identity up here, it tells you sine squared plus cos squared equals 1, which means if you did 1 minus cos squared, you would get sine squared. So this could then be written as sine squared x over tan of x. Now the other thing you need to do is keep one eye on the prize. So keep one eye where you're trying to get to. So I want to get my left hand side to be equal to my right hand side. Now notice that the right hand side has no tans in it. So I'm going to change my tan on my left hand side to be written as sine over cos. So what we really have then is sine of x divided by sine over cos. And then if we just do that, if you divide something, if you had sine of x divided by sine over cos, so as a fraction, write your sine as sine over 1. How you do dividing fractions, that's sine x over 1 times cos x over sine. And then that will work out to be, and what happens, you can see the sine, I'll put a nice neat line through it, the sine will cancel on the bottom, the sine will cancel on top, leaving you cos over 1, which is just cos, and please tell me that's what we were looking at. It wasn't. What have we done? I missed something? Oh, I have. Look what I've done. Okay, here, very good example here of how we must check where we're going. Now, if you look here, that should have, in this line, that was a sine squared, so that's sine squared. So that just cancels out. Actually, one of my sines get cancelled down, so it just cancels down to the wee squared bits gets cancelled out here. And then that will leave me with just sine times cos. So there, made a wee mistake there from this line to this one, but there we go. So next one we're going to look at, finish it off just by saying you're right, that equals your right hand side, and then you know you've got it right, you've got full marks, happy days. Okay, next one, try not to make any mistakes in this one. It said cos of a minus sine of a squared is identically equal to 1 minus 2 sine a cos a. So we're going to look at our left hand side. So it was cos of a minus sine of a squared. So let's just write that out as cos of a minus sine of a upon cos of a minus sine of a. And it is just the multiplying out the brackets. Cos times cos is cos squared. Cos times the minus sine is minus sine a times cos a. Then you've got minus sine a times cos a, so minus sine a cos a, and minus sine times minus sine will be plus sine squared a. So let's just write that again. That's cos squared a plus the sine squared a. I'm just grouping those together. And then my minus sine a cos a minus another sine a cos a, or minus 2 sine a cos a. And that's just 1 minus 2 sine a cos a, which, happy days, is equal to your right hand side. So a nice, very easy one there. Just multiply the brackets, tidy up. Some of them are very easy, some of them they're definitely not easy at all, and there's maybe a wee trick you need to see. Okay, the next one doesn't look easy at all here, D. But we'll see, maybe it is when we get going. Okay. Right, we're going to look at our left hand side, and it was sine squared x And then 1 minus sine squared, I could write that as cos squared x. And then this thing in here, I'm going to change it. Remember we said that tan x was equal to sine x over cos x. That means tan squared x would be sine squared x over cos squared x. And also it means 1 over tan squared x then would be equal to the reciprocal of that. It's going to be cos squared x over sine squared x. So what this inside this third bracket here, would be 1 plus cos squared x over sine squared x. So that's what our left hand side is. Right, inside this bracket then, this last bracket, nothing we can do with the first two terms, but inside this last bracket, take a common denominator of sine squared. So it now becomes, top line is sine squared x plus cos squared x, and then that's now sine squared x, cos squared x times 1 over sine squared x, because remember sine squared plus cos squared is 1. And then all we can do, if you imagine you put that all over 1, it's just multiplying fractions. I could cancel out my sine squared with my sine squared, which just leaves me cos squared x times 1 on the top line and 1 on the bottom line, so which is just cos squared, which is equal to, hopefully, it is equal to my right hand side. It is. There you can see that proof in its entirety there. So pause the video if you need to and work through that one. Okay, a couple more to go. Right. In this one here, I've got tan b plus 1 over tan b is equal to 1 over sine b cos b. Now, again, we'll work with our left-hand side. Instead of writing tan b, I'm going to write sine b over cos b. And 1 over tan b then would be cos b over sine b. So it's a common denominator one again. My common denominator, I'm just going to write it as cos b over cos b sine b. So just multiply those two denominators. So if you think, how did I get this cos b to become cos b sine b? I had to multiply the top line by sine b. So its top line gets multiplied by sine b, so that becomes sine squared of b. How did I get this denominator to become cos b sine b? I needed to multiply it by cos b. So I need to multiply its numerator by cos b, so it's going to be cos squared b. And then top line, you've got what sine squared plus cos squared, which is just 1. And the bottom line, rewrite it as just sine b cos b. And then that equals the right hand side. So we know we've got it right. Okay, last one. Whoa, okay, right, look at this one. Right. Okay, I have no idea. Right, let's just get started. Right, this is going to be a tricky one. We are going to have to really work with our left-hand side. We're going to have to be very careful here. We're always keeping one eye on the prize. So we want to get what we have on the right-hand side. So let's see what we can do. And notice they've got a tan in their answer. So I don't really want to get rid of my tan here, or do I? I don't think so. I think I'll maybe change the tan on the first one. Let's just rewrite this out as sine theta cos theta. I'm going to change this first term to be sine theta cos theta times 1 over tan theta. So that's what I'm changing this first term to. And the next thing, I'm just going to leave it as 6 tan theta minus, I can take a common denominator for these. Sorry, what am I doing here? I guess it's going to work out very quickly actually, but it's tough to see it. Right, what I'm doing, I've done this first term here. This has become this thing here in yellow. Now the second two terms, if you notice the second two terms already have a common denominator, so we're just going to push them together as one term. So both of them over tan theta, and then it's going to be 6 minus 6 sine squared theta. Now, this first yellow bit then, sine theta, cos theta, and 1 over tan. Remember, tan is sine over cos. Let me just write that down. Tan is sine over cos. So 1 over tan is just that upside down, so it's going to be cos over sine. So that's just going to be cos over sine. I don't want to do too much in one line. And then here, this left-hand bit, sine and the sine cancel out. Cos and the cos cancel out, and that just leaves you 1 over 1 times 1 over 1, which is just 1. Now leave this alone. This is sacred because you've got a 1 in your answer, so you don't want to be going around messing about with that 1. So we've just got this next bit to sort out. So we had 6 minus 6 sine squared theta all over tan theta, and then we'll go on with this. Okay. I'm going to factorize this top line. Factorize out of 6, which would leave me, there we go, would leave me 1 minus sine squared theta. And then that is 1 minus sine squared is a cos, same as cos squared. So that's 6 times cos squared theta over tan. And I think that's the same as my right hand side, is it? Let's see, my right hand side, yes, they had it just 6 cos squared over tan. And plus 1, so I had 1 plus 6 cos squared, which is the same as my right hand side. That is difficult. Okay, that's not an easy one. It's quite quick when you do it that way, but it is tricky. Now the hard part now, folks, is looking at your answer and thinking, right, I've got a 1, so I want to get a 1 somehow, and also I've got my tan on the bottom line, so I don't want to really mess around with the tan on the bottom line. So that was a bit of a tricky one there, I have to say.